Well, hello there. We're going to have a look at some exponential equations, short and sweet today, but something you do need to get right, okay? And you need to get confident with them. So let's have a little look and see if I can make them nice and easy for you today. So we have to find the value of x for which 4 to the x equals 256 and for which 3 to the x minus 1 equals 81. Well, how fascinating. Now, let's go with number A. Now, this is the confusing thing with this is that the x is in the exponent. So that's where the problem lies. But it's easy to overcome it. Easy to overcome it. If we express this right-hand side in a similar form to the same base as we have over here with a base of 4, everything becomes easy. So you have a look. So 4 to the x equals 256, but 256 in turn is 4 to the 4. If you work it out, it is. So therefore, if the bases are the same, guys, if the bases are the same, then so must the exponents. Therefore, x equals 4. Yes, need I say more? I know. So that's as easy as that. Here comes number B now. So similar technique. We've got 3 to the x minus 1 equals 81. So we set out to express 81 as 3 to the something, and then once the bases are the same, we can then just equate the exponents. That's the deal, right? 3 to the 4. See, 3 3s are 9, and 9 3s are 27, and another times 3 gets you 81. So it is 3 to the 4. So therefore you can say that x minus 1 equals 4, and therefore x would equal 5. How marvellous! Now here's the index laws. This is revision for you. Okay, so we know that a to the m times a to the n equals a to the m plus n. You know that you add the exponents if the bases are the same. If you're dividing two numbers, you know that you subtract the exponents, don't you? A to the m divided by a to the n is a to the m minus n, right? This is very, very important for you for setting the scene for the log laws, because log laws are just index laws restated. That's all they are. Confusing as they look, they are not anything other than just index laws restated. Okay. To raise a power of a to another power, you multiply the exponents. So a to the m times a to the a to the m bracket to the n is a to the m times n, right? And we also know that a to the 0 or anything to the 0 equals 1. So there's your index laws. You need to know those very, very, very well. Okay, let's do some more of this stuff. Well, come on, why don't you pause the video, have a go, and see whether you can do them and come back. I'll wait. You right? Have you had a go? How did you go? Well, strategy. Make this base a 5, not a 25, because that's 5 over there, yes? And strategy for this one, I think this is all about 3 to the x. So see, make this as a base 3 as well, right? That's the strategy. Anyway, we'll just go with A for now. So we've got 5 to the 2x minus 4 is 25 to the minus x plus 2. Now 25 is 5 squared. So let's just re-express it like that, right? 5 squared to the minus x plus 2. Now you know what to do when you've got a power raised to another power. The index laws on the previous screen, what do? You multiply, right? You multiply the two exponents together, this one with this one. So now we've got this now. Now look guys, the bases are the same, therefore we can equate the exponents, and what do we get? We get that. Solving for x looks very simple, and x looks like it's 2. For me and you, woohoo! Isn't that great? So easy, so easy. That's the key. You must make the bases the same. Now this one here, this is a little bit tricky in a certain way, so we'll just step our way through it. We've got 9 to the x equals 12 times 3 to the x minus 27, and therefore now this is, watch this guys, see I'm trying to make this 9 with a base of 3, which I'm saying, okay, that's fair enough. 9 is 3 squared to the x, and the rest of it's the same, right? Now, what I'm going to do here is a little switcheroony. See, I've got 3 to the x in a bracket there. Well, I really want 3 to the x in a bracket over here. So I'm just simply going to watch. It's like the pea and thimble trick. I'm going to put the x in there and the 2 out there, and you watch. How sweet it is. Now, I've got 3 to the x in this bracket, 3 to the x in that bracket, so that's looking great. So now, it's really a quadratic in, yes, it is. It's a quadratic. Something squared, like this, only it's 3 to the x squared, equals 12 times 3 to the x minus 27. So to avoid all the confusion of this funny looking beastie in here, we'll just call it a single symbol. That's what I always do, and it just makes it easy. So what we're going to do is we're going to call 3 to the x u, and we will rewrite that equation in that way. Okay, we'll rewrite the equation in that way. Then once we get out of danger, we get some values for u, we'll then re-express it in terms of what u really was. So if you don't get what I mean, I'll show you. So this means, look, u squared equals 12 times u minus 27. Now that's a quadratic if ever I saw one. So let's just fiddle with that and solve it for u. Now come on, you know what factors of 27 are that you can add to 12 or get 12 out of. They're going to be 9 and 3. And because this is a positive and this is a negative, that means that they'll both be negatives. So there it goes. Right? So therefore u would be 9 or u would be 3. As easy as that. Now, we're out of danger. We're unconfused, so we better go back to what u was now and resume that little dance with Mr. 3 to the x. So 3 to the x equals 9, or 3 to the x equals 3, but it's just not confusing anymore, is it? Because once we put that as a base of 3, that's already a base of 3, that's 3 to the 1, we're out of trouble. So 3 to the x equals 3 to the 2, or 3 squared, or 3 to the x equals 3 to the 1, therefore x equals 2, or x equals 1, and we are done. Yes? Alright, now just to finish this off, I've got some index gobbledygook for you. Ugh, yuck. Go and pause it, have a go, and then come back. Will you please? And I'll wait for you. Right, how did you go? Yes? You went alright? Well, that's great. Well, come on, let's see what I got. Here's A. Now, you've got to remember with this one that a lot of students forget that everything in that bracket is squared, including the 4. Did you forget that? Hopefully you didn't. So basically it's 16 x to the 8 y to the 4 plus 2 times x to the 8 y to the 4. So looks like we've got x to the 8 y to the 4 terms here. So they're similar terms. So we've got 16 of them here, and we've got 2 of them there, which makes a total of 18. So 18 x to the 8 y to the 4, and we've got it. Yes? Great. Did you get it? Well, that's good. If you didn't get it, just remember, go back and see where you went wrong and practice, and you'll be right. What about B for you and me? Now that's, okay, well there's a trick here. Look, what's x to the 0, guys? It's 1, isn't it? So that's just 4 squared, and 4 squared is 16. It's as easy as that, right? What about number C now? That looks like a particularly beastly looking piece of work. This dividing sign is a big problem for a lot of students. You just put that as a vinculum, and you've got this over this whole thing, right? Vinculum is the dividing line between the numerator and the denominator. That's what it's called. So what have we got? We've got 15, getting rid of that bracket, x to the 20, y to the minus 8 over 3 times x to the minus 8, y to the minus 2. Now, what did I do with that, guys? What I normally do, well, the 3 goes into the 15 5 times, right? So that's sorted that out. This is a minus 8. So if you take any minus exponent, put it up to the other place, in this case the numerator, it becomes plus 8. So that's x to the 28. Now this one here, what I've done there is I've basically put this guy, being the lesser of the two animals, I've put him up there as y to the plus 2, and then that becomes y to the minus 8 plus 2, which is minus 6. Now, if you wanted to express your answer with positive exponents only, although this answer is perfectly correct unless you're asked to express the answer with positive exponents, you could also you could write it with positive exponents as 5x to the 28 over y to the 6. But that doesn't mean this answer is not correct. It is. All right. That's it. That's it. Exponential equations done like a dinner. And you're a star and you'll go far. Go and practice and multiply your maths. And we'll see you next time. Bye.